Okay, hi everyone. Follow that. That's very impressive there, Tom. So, I'm Peter Shorrock, an engineering manager from Resillion. It's my colleague Jiang.
Hello.
He's a senior software engineer, also from Resillion. We're here today on behalf of the CTA Wave group to present to you the Wave Streaming Media Test Suite. For the remainder of the presentation, we'll simply call it the test suite, just to make our life a little bit easier and avoid a lot of repetition. And for the next 20 minutes, what we'll do is we'll take you through who are we, who is CTA, if people here aren't aware of who they are, what is the CTA Wave project, why it matters, and to give you some detail on the test suite, to show you a demonstration. I'm going to be providing you the sort of high-level context, give you a little bit of background as quickly as I reasonably can. The majority of the presentation is going to be done by Jiang. She's going to take you through in some detail the test suite and also give you that demonstration. And then hopefully there should be time left at the end for any questions or clarifications people may have. Just also mention a couple of names on the slide there, John and Lue. They're also part of the CTA Wave group. They produced the original slides that we've slightly amended for today, and you may see them also promoting this elsewhere, so we're not the only people going around to promote this. So who are we? Resillion. We're formerly known as Eurofins Digital Testing. We're a global quality engineering and cybersecurity company. In the connected TV space in the UK, an example of work that we've done is the development and distribution of testing materials for Freeview Play and Freely for device performance. We've been part of the CTA Wave project for around about 7 years now, so quite a while. And we're one of the key contributors to the test suite, so we've developed the observation framework, so when Yen takes you through, you'll see that. As a company, we very much believe in the benefits that this test suite can bring, and we back that up by the fact we have integrated it into all of our own test tooling as well. So, who are the CTA? The Consumer Technology Association are a standards organisation and trade association based in the United States. Their aims are to support, promote and drive innovation and collaboration across the wider consumer electronics industry. And if you haven't heard of them, I'm sure you will have heard of their annual trade show, CES. So, what is the Wave project trying to solve? So the Wave project aims to improve how internet-delivered content is handled on consumer electronics devices, so for example smart TVs, media sticks, and mobile phones, and to make it easier to distribute the content to those devices. So to address this, the Wave project has produced some specifications and open source tooling, which if widely adopted could help improve interoperability with a common set of tests that everyone interested in internet content can use. And this is why the Wave project matters. So this here, apologies, quite a lot of information. I should add the slides that I'm quickly rattling through here, and they should be able to be made available afterwards, so you don't need to write them down. And the slide pack, it is a bit of an information pack, so it's intended to be able to signpost and allow people afterwards to go and look at this information. So we're not going to go through all of these specifications and test suites today. One that we are calling out particularly though is the device playback capability specification. So that's what the test suite that Yen's going to take you through today, that's what primarily defines it, that specification. And within that specification, it's mainly focused on the playback of CMAF content using MSE and for some of the tests, EME. The tests are defined in sections 8 and 9, which are called out here, so you can read the initial tests that are being released as part of this test suite there. These are intended to be key scenarios to be tested to exercise the relevant APIs. Both video and audio is in scope. And you can see for some of the tests that's focused on single track media playback, so it's video tests and audio tests. Section 9 is looking at where those presentations are being played back jointly, both audio and video. These are intended to look at real-world scenarios where interoperability needs to be assured, and the group here is quite keen to get any feedback on any gaps that people might see and to extend out the testing. Okay, so I think that's all of my bit over with. Apologies, that was quite quick to get through there, but I need to do it to keep us on track. I'm now going to hand over to Jiang, and she'll take you through the test suite in detail and talk you through the demonstration.
Thank you, Peter. Hi, everybody. Now I'm going to go through in-depth overview of the test suite. It has a collaborative effort with contributions all over from different partners, including us, Resillion, who deployed the observation framework. So I'm going to go through a bit more details about test suite and its applications. It contains 5 key main components. We do begin with the mezzanine contents pool, which contains annotated source streams to enable automated observation, followed by a wave test contents pool, which contains a CMAP test content generated from the source mezzanine and encoded in different codecs and formats. After that, we have test instructions, which based on HTML and JavaScript templates, and it's implemented based on device playback capability specification. After that, we have a test runner, which is a server based on W3C's web platform test. It's managed the entire test run. Last but not least, we have observation framework. It's conduct the automated observation that is defined in the DPC specification and delivered pass and fail result. The device observation framework processes the data based on the input streaming that is captured by a camera by pointing to the device screen. Next, I'd like to go through a bit more details of every single component. So I'd like to begin with the mezzanine contents, which is annotated video contents in many different resolutions and a frame rate, which been generated from different source materials. For example, we do have Tears of Steel in 60 Hz group. What you can see on the screen is seen from Croatia that covers 50 Hz group. And then we do have Big Buck Bunny for air decision test in splicing test. And we added a green frame. First frame is a green to be able to help manual debugging, and there's a red frame in the end. So the video automations that built into the video include the QR code, which can be used by observation framework for automated testing, along with some other annotations that can be used for manual observation as well. For rotating QR codes on the left-hand side of the screen, that contains information such as frame rate and media time. And we do also provide a human-readable text format to help debugging, which contains same information that embedded into QR codes. On the top right, we have a flashing little box, which can be used along with a beep for AV sync manual testing. Although we haven't used this on this test suite, but there are beat patterns on the top left, which is designed for the TV manufacturers. They can use wave test material to their white box testing. Last, there's 4 red triangles around the edge, which can determine whether or not full screen is visible on the device. And in terms of audio automations, we do introduce a pseudo random noise, which is generated from unique beat patterns and then output a unique random noise based on the unique string. So the wave test contents is being generated from mezzanine contents and encoded in a valid wave media profile that is defined in the wave content specification. This contents is then segmented into CMAP standard and accompanied by a dash manifest. The CMAP streams are organized into groups, and a matrix is available to document test contents and different options for each codec. The contents have been validated as compliant with CMAP standard using the -if validator. We also call it JCCP validator. And we also implemented a script to ensure that each options are correctly applied to the streams. After we got contents, we do have a HTML and JavaScript templates to tell the and tell the TV to display the CMAP streams. So for the HTML JavaScript template, we have available for each different type of test that is defined in the DPC spec. For example, we got a sequential playback that plays CMAP video from start to end, also for audio as well. We do have random access fragment and random access time test, which is basically jumping to the middle of the track and then play back to the end. And also switching set for resolution switches and frame rate switches, and have baseline splice test for exercise insertion. There's a few more type of different tests, such as long duration tests. I'm not going to go through every single of them. There's lots of good tests. And for the templates, it's available for audio and video only for Section 8 tests that we mentioned earlier in the DPC specification, and also video and audio tests for Section 9 tests in the spec. While the test is running, the test runner overlaid information on top of the playback, which can be used for the observation later about observation framework, which contains useful information such as test status and the timestamp. So comes on to the test runner. The web test runner is extension of the original WPT server that's facilitate testing in a single window. Now we have extended that to be suitable to run on the embedded devices such as TV. When the test is running, it's made available for the user to view the status and then view the result on the second devices, which is particularly useful for the devices that has no tabs. So it's quite handy for user to monitor the test on their companion device. And we do have a REST API for test automation, which can be integrated to other systems. For example, we have added into our HBBTB testing tools. The device observation framework mainly conducts the observations and defined in the DPC specification and reports the result back to the test runner. This framework can be operated on the same PC that runs test runner, or alternatively, it can be run on more powerful PCs in terms of the requirement. To ensure comprehensive analysis, the camera must be record the entire duration of each test run. The observation framework automatically analyzes the input recordings, extract the information, and processing the data, and compare the result against the DPC specification. The framework includes capability of video observations based on the QR code extraction, and also audio observations based on the information captured by audio waveforms. In the next slide, I will provide a bit more details of every single of them. To begin with video observation, the observation framework reads the provided recording frame by frame, scans the QR code and detects it, extract the information from the QR code that can be used to determine different observations, such as whether every video frame is rendered, or it's in the increasing presentation order, or startup delay is within the tolerance, or playback duration matches the CMAP duration. We do have 3 sets of different QR code information can be captured from the test run. Begin with the pre-test QR code, which is presented before starting of the playback, which contains information of test code. We can use that to retrieve information of the test that is currently run on. Also, it contains a unique test session ID. Observation framework use it to report the result back to the test runner. And second set of QR code is mezzanine QR code, which embedded into the mezzanine contains information, as I mentioned earlier, such as frame rate and frame numbers and media time and so on. And the other set of QR code on the right-hand side is overlaid by test runner JavaScript. It contains important information for observation framework to use on making observations, such as the media time, and then current time, and test status and action, and so on. So for the audio observation, it reads the audio wave data to detect audio segments. Audio mezzanine is cut into small chunks in 20 milliseconds. Cross-correlation algorithm is used to compare source mezzanine with recording and obtain the offset of timings for each audio segment that is presented in the recording. We got a diagram that is captured by observation framework log, and which shows the offset of timings is straight in line, which then prove that most of audio segments are in order and as presented. If you look really closely, and there's one drop out at the end and then two near the front. So we would like to proceed with demo that is tagged in the front of the TV lab, and it runs on one of the HBB TV device. When the device under test loads the test runner index page, a QR code is presented on the screen. By scanning QR code from the companion device, user direct to the configuration page where they can select the list of tests they wish to run on the TV. And after selecting the list of tests they are happy to run, and there will be a button on the below to start the test. So now you will see the test will on the screen. And here is the pre-test QR code that I mentioned earlier, which contains information of test code and test session ID. And now the stream started to get playing. And then we do have a rotating QR code on the left-hand side, and then we do see the status QR code on the right. We're using a webcam, we're using the smartphone camera to capture the entire duration of tests, so that it can be used later for observation framework to analyze. And I'd like to highlight that we used the inline audio recording. Microphone and speaker recording is not yet supported by Test Suite. I will go into more details about the camera recording requirements later after this demonstration. Right, so now we see the last red screen that is embedded into mezzanine, and the test session is now completed. After that, user can see the test result from the companion device provided by test runner result page. After that, user need to copy the recordings from the camera and then load it to the device that contains observation framework, and then initiate observation framework process by providing the input location of the recording. After observation framework finishes its process and it's inject the result back into the test runner, so that all the result is available to view by the user from the test runner result page. This is an example of the result page that looks like on the test runner. We do have a result such as pass or fail, and together with the message explaining the reason of pass and fail. As you can see here, we do have every sample rendered, failed, and it's saying the first frame found 8, expected start from 1. That's indicate frame number 1 to 7 are missing. And also it gives detailed total missing frame counts. The test runner result is in 2 different formats. As you can see, it's in HTML, and also it can be downloaded as a JSON format as well. The CTA web streaming test suite is compatible with different platforms such as Linux, Mac, Windows. However, we do suggest to use the Linux just because of its native Docker support, which helps people to easily and fast install the entire test suite. Please also ensure that TLS server certificates are obtained, as this is essential for the EME encrypted testing, which require HTTPS. For video recording, in order to capture it efficiently, we suggest around twice the frame rate of the displayed contents. So for the higher frame rate contents, such as 50 Hz and 60 Hz, we do recommend to use camera that can capture around twice the frame rate, which is 120 Hz. For audio, it should be recorded at 48 kHz and then 60 bits. And a wired audio recording shall be used. If recording is done over the microphone and speaker, it might not comply with wave standard because we do have echoes and background noises, and also distance from the TV speaker and camera microphone may lead into false negatives in AV sync testing. So for the validation of each test, CTA Wave validate test suite at the HBB TV Plugfest. Currently, we do have some video tests that are being validated following the previous Plugfest events. The next Plugfest is scheduled in October, which is this week, and we are expecting more video and audio tests are planning to be tested and validated. So where to start? We do encourage people to visit the CTA Wave landing page, where we can find the information about test suite. Feel free to read it, it's freely available. And also we will provide the link to the deployment GitHub repo, where you can download a setup package to try and install the test suite. I think that's the end of our presentation. Thank you very much for taking time to listen to our presentation. We try to answer any question if you wish to have. Thank you.